so confident that I was gonna get like 100%. I know.
All right. Okay, Pete, take off your coat. Stay for a while.
I don't want to stay for a while.
Then there's 27 doors in the building. Pick one and use it.
Why only 27? Why not 30?
Because that's how many doors there are in the building that lead out to the outside.
That's true.
Sure.
Actually, there's already 400. Oh my god, it is.
Here's the map. All right. Here's the map. 27 doors. Lead out. Pick one if you don't like being here.
Well, then there's going to be more doors with the new weight room. So
Correct. But right now there are 27 doors. Actually, okay, then there's 26 because you can't get out through the gym.
Yeah.
You still have multiple choices.
Oh, I put the decimal in the wrong spot.
When can you retake a test? Like, what do you need to have?
Well, you need to get all the corrections
Oh my
done, and
God,
then
I
you need to turn them into me. Let me look at them.
Well, I mean, like, what did you need to get on the test before?
You need to have a score of less than a 70%.
What do you mean it's wrong? Can you come here and
Can I,
check this?
can I get them all handed out first?
Oh yeah, sorry. What?
She's just too excited. What do you mean?
What the heck?
Oh, I'm stupid.
That's like 28 cents.
We will go over it. I will explain, and then if you have questions, I will be happy to answer those.
Oh my god. Like, why is that wrong? How is that wrong? How the freak? It literally is one of the 7. Oh, please. Then, okay, what did you put here? That's not right. Is that not right? So which law is it? Yeah. So which law did you put here?
All right. Now, please understand, ladies and gentlemen, some of these problems could have been solved in different ways. Yes.
Why didn't I get the point so they get loose hacks? I didn't know how to spell his last name.
What did you put down?
Gay.
You got to give me more than that.
What are you?
Gay, the gay person. He was happy. I don't care. Well,
What was the answer for number 9? I'm so
hold on. I'm going to show you. All right. So if you have, ladies and gentlemen, version A, here are the answers to the first 3 questions. So we'll go through it page by page. We'll start with A. Oops. All right. So in Sig Figs, there are your answers for A. For number 2, I'm sorry, version A, number 1, 2, and 3, ladies and gentlemen. There are your answers for them. Please remember, for full credit, you had to have the right units, you had to have the right sig figs, and you had to have the right number. And some of you, you need to work on punching numbers into your calculator. Because seriously, I did the exact calculations you had set up, and I came up with different numbers than you sometimes. So, any questions on A, 1, 2, or 3? Okay. Here's B, 1, 2, and 3. Big one was when people calculated the R value, they didn't give me all of the units. The units were ISP times liters over mole times Kelvin. Any questions on version B?
We have to find how to moles for all of them.
there were other ways you could have done this. But the thing that you had to do first was you had to find the pressure of A, because it's the one that you had the moles of as well. Now, in this step here, you could have set up a proportion for the pressure of A over the moles of A equal to the pressure of B, whichever one of these this is. I don't remember off the top of my head. This pressure, okay? And you could have solved for the moles of B that way. So you could have set up a different proportion if you wanted, but you had to set up a proportion somehow relating either partial pressure over total pressure to moles over mole total, or the moles of A over the moles of B compared to the pressure of A over the pressure of B. But this is what you should have ended up with. A lot of people on this one solved for N, but they forgot that N was the number of moles, not the number of grams. So they stopped there. You had to then use formula mass to get it into grams. Other questions on version B? All right, if you had version C, these are only the first two questions. I'll show you the third in just a second, ladies and gentlemen. So for this one, a lot of people ask me, did I need to use the mass? Yes, you did. You had to use the mass. Now, you could have done various things. In this case, I took the mass and calculated it into moles, put it into PV equals nRT. The one thing we couldn't do is we couldn't just assume that it was 22.4 liters. Why? Because of the fact that that's not 1 mole. It gave us a certain amount of the substance. So when we ended up solving for this, we ended up getting it into degrees Celsius because that's what it was supposed to be in. Questions? Second page of version C. So in this one, again, somewhere along the lines you had to find the moles of B. Could have done it different ways, but that was the moles of B in number 3. Here was your R value for ISP times liter over mole times Kelvin. For this one, you could have found the volume using PV equals nRT, or you could have done it using combined gas laws. Once you have the volume, you also have to have the correct formula mass. Formula mass divided by volume gives you the density. Here we have the density of A over the density of B is proportional to the masses. Many people forgot that fluorine was a diatomic compound or a diatomic molecule. So you ended up with a smaller number here, which gave you half of that. Questions? All right. Version B. Here are the 3 problems on this page. Again, the one that was on the bottom of the other one, getting it to the temperature in Celsius because it specifically asked for it. Converting what you were given into moles, plugging it into PV equals nRT, solving for T. Here, again, the density. Again, formula mass of fluorine over carbon dioxide would have given us a density here. PV equals nRT or combined gas laws, either one will get you the volume of the gas, 22.85 liters. Taking a mass divided by the volume gave us 6.73. Questions? Version A, ladies and gentlemen, there's what you got for the first one. 3.2 ISP times liters over mole times Kelvin. Again, in here, you could have used the pressure of A to find the total moles and then use the total moles to find the moles of B, but there were other ways of doing that. Here, ladies and gentlemen, a lot of people, a lot forgot that liters or milliliters need to be liters here. So your answer ended up 1,000 times too big. because you did not convert milliliters into liters. Okay? That's why this came out to be a very small number, and that's why this came out to be a very small number. Questions? Okay. For number 7, ladies and gentlemen, there is what happens to the factors. As you go higher up into the atmosphere, we said there was less air around it. That means pressure is going to decrease. According to the graph, the temperature was increasing, and because it was a sealed balloon, that means the amount of gas has to stay the same. Pressure going down will cause an increase in volume. Temperature increasing will cause an increase in volume. Something that is constant can cause no change. So what ultimately causes the balloon to explode are the pressure and temperature both increasing. It was interesting to see people tell me that pressure caused it to explode when you said pressure would cause the volume to decrease. I don't know how that can be. If something is decreasing in volume, it's not going to explode. Now, I tried to be generous here, and what I mean by that is, if you understood that pressure was in an inverse relationship with volume and you accidentally put that it increased here, I marked that wrong, but if you put that it decreased here because that is the relationship, I gave you credit for that. Even though it's not right, I gave you credit because you knew it was the opposite way that pressure was supposed to go. These two had to be going in the same direction for you to get credit here, and this had to be no change. Okay, that had to be no change. Kelvin has to be the temperature that we use for gas laws. Why? No negative numbers, and the changes are not so dramatic as our temperatures on Earth.
That's for 8, right?
That's for number 8, yes. Version B, the 4 factors that affect the gas: pressure, volume, temperature, and number of moles or amount of gas, the definitions, and the possible units. Here is what I expected to see down in that section, ladies and gentlemen. Again, Avogadro's relates V and N, and it is a direct relationship. Boyle's relates pressure and volume. Gay-Lussac's relates pressure and temperature at a constant volume and amount of gas. And Charles relates volume and temperature at a constant pressure and amount of gas. These two are direct. This one's direct. This is the inverse. Same answer for number 9 that I just gave the other group for number 8. Which is that has to be in Kelvin, no negative numbers, and it isn't such a dramatic swing as it would be based on our temperatures here on Earth. If you had version C, you had the same 3 questions on this page, just in a different order. So, these were worth 12. These were worth 12. This one was worth 3. Okay, for version A, again, same thing as I went over just a minute ago. Pressure is decreasing. This one has to go the opposite direction because they're in an inverse relationship. Temperature is increasing, same direction. Gas is not changing. This had to be no change. What causes it to explode is the pressure and the temperature. Both are causing it to increase. Both make the balloon explode. Again, our answer once again for Kelvin, what unit it must be in, and things like that. Okay. So again, you have already seen these. Same answer key as it was for the other versions of the test. Up there, here. These, they have to be in a certain order. These, it didn't matter because you got to pick which one you were talking about first anyway. So, and then our definition of chemistry, the science of the study of matter, its structure, properties, composition, and the changes it undergoes. Had to give me that whole definition to get 3 points. If you missed 1 or 2 words in it, I gave you 2. If you missed the majority of it, I only gave you 1. Questions? Okay. Again, I had ideas in mind for these, ladies and gentlemen, but if you gave me something that fit, I went with it. Okay. So the 5 elements, ladies and gentlemen, were sulfur, oxygen, carbon, and iridium to make soccer. The 4 elements that a science teacher would enjoy would be sodium, phosphorus, and sulfur for naps. And which is correct? 8 and 8 is 15, or 8 and 8 are 15. 8 and 8 is not 15, so neither one was correct. 8 and 8 is 16.
Oh, yeah.
So,
Well, that's wrong.
questions?
Anyways, this would be it.
Now, again, ladies and gentlemen, the next thing that I would do is, if you don't have any questions on my correcting of the test, I would check my arithmetic on your grade. I do not use a calculator when I add up the corners to give you the total that is on the front. Double check and make sure that I have graded them correctly. Yes?
Wait, what was the definition of chemistry?
The science of the study of matter, its structure, properties, composition, and the changes it undergoes.
Is it because I didn't put science?
Well, that is part of the definition, right?
Yeah.
So. Yes,
I
Austin.
wrote soccer, but you have to.
It said what 5 elements?
I had to write it out.
You needed to give me the elements. Yeah. Yep. So, by the way, the other one that someone came up with for what science teachers like was cobalt, fluorine, and iron for coffee. I took it. Good answer. Somebody tried to stretch it. They decided tenon instead of, I think, tennis
Oh, no, I
for
was trying to write
the
tanning.
activity. What?
I was trying to write tanning, but there was no
Tanning.
G.
That's what I was looking for too.
Okay.
Why is there no G?
But then I
Yeah, I know. There's no G on the periodic
I know.
table that you
There
could
should just be,
use.
like-
So
It should just go in alphabetical order.
I put 2 and 2 together and remembered he's a hater and that he doesn't like soccer. So
okay. Well, at least I made it an easy question for you then. So, okay.
But
Any
like,
other
why can't like male students do soccer?
What?
because it's not a spring sport for them.
Because it's not a spring sport for
But you,
them.
well, they.
So I was
there's
trying
clubs.
to. I was going with school sports, spring sports. I was trying to limit it down for you so that you had a better shot of getting the answer that I was asking. So, all right. Again, ladies and gentlemen, there are some things that I love to do. I love to golf. I'm not going to call it a sport, though. My goodness, it would be terrible.
golf is a sport.
Why?
Golf is not a
As the
sport.
stupidest thing in the world to do. What's the basis of golf?
You actually
You take and you hit a ball away from yourself, and then what do?
But here's
You
the
go
thing.
chase it down, and if you're lucky enough to find it in a huge field, what do? You hit it away from yourself again.
But like you say that baseball's hard because you're hitting a small bat with a small ball with a small bat. But
Yeah.
in golf, you're hitting an even smaller ball with an even
Right,
smaller.
but with no. Have you seen some of the club heads are like swinging a small car?
Okay,
at the-
but
that
you
deep
have
ball.
to be accurate.
But they're
It's
still
like
smaller
seven
than a
No,
bat.
I'm not saying that all of those things don't happen.
So it's like it's technically.
And here's the other thing in golf: the ball's not moving.
Yes, it does.
In baseball, the ball moves as it comes toward you. That makes it a little bit harder.
Okay, but then there's winds and there's hills and there's like you have to hit it slow.
The
you have to
water.
hit it hard. You have to
Mr.
hit it
Brand.
at an
So
angle.
what's your point?
So it's a sport. Get out of here.
Mr. Brand,
What
what
is
is
not a
your
sport?
definition of a sport?
Okay, my
Basketball,
definition.
football,
No,
baseball.
it can't
Sorry,
be a
softball.
list.
It can't be just a list. That's not
Okay.
a definition.
All right, my definition of a sport is the sports of baseball, softball, football,
it can't
basketball.
be a list. That's not a real definition.
What about like flag football?
That's like
7-on-7.
Kinda, okay.
that's like if
I'll let it
someone was
go.
like, "What's the definition of an element?" and they
What
were
about
like,
swimming?
"Lithium, sodium."
Swimming is a sport. How is
They listed
volleyball
on
a
the
sport?
Well, how is swimming a sport?
How is
What is your other option?
what do you mean?
What is your other option if you don't swim? You will drown. That's called survival.
You would drown.
That's not a sport. That's surviving.
That literally drop my
What sports do you
my grade down a letter.
What sports do my kids do? None
Like
now.
half a letter.
Well,
then
you
A,
used to.
like high A, now
My
A.
daughter
Low
did
A minus.
softball, volleyball, and basketball.
Yeah, honestly.
My
See, you
son
said-
did
Honestly, I'm gonna cheat
basketball.
right now, so.
He did cross country as an activity, which is the dumbest thing ever.
See, I told you. I asked you what sport.
Cross
you
country
played. You said
is not a
volleyball.
sport.
You said.
Well, according to
cross
your
country.
definition, not
Oh,
mine.
that's what you said. I asked you a sport.
There is.
See, volleyball can be a sport because it's just you throw a ball over net and hope somebody throws it back. So,
Actually, you don't throw it, you hit it. If you catch it, you're out.
okay, you're out. You have to leave the game.
I bet like you lose a point if you catch it. Just like in soccer. You can't
Oh,
catch it, you're
But
out.
soccer is not a sport either. So.
Oh my god.
You're not a sport.
Same thing. But
I'm
it's
not a sport. I will admit that. I'm not.
You're funny.
Girl. What is this?
When I go D1, I'm not gonna remember you. I won't shout you out.
That's crazy. 72. That's not.
All right. So, ladies and gentlemen, there you go. There is your grade report. If you have something highlighted in pink, it means that is missing, ladies and gentlemen, which means that is lowering your grade. If you turn it in, you will get some points for it, which is better than the none you have right now. Hello.
You're late. Get those sweatpants. Where'd you get those sweatpants?
By the way, Sophia is going to be part of our welcoming committee from now on, because when you walk in and she's like, "You're late," that's the way we like to
Did I
treat
really
people.
say that? You're late?
Yeah. Yeah, I don't think she even made it in the door before you were yelling at her.
I shouldn't have stayed this morning. This lab. So now we're
Next Friday. This Friday. Why is it today? Today's a Tuesday. Why?
75.
Do I get to leave?
Did you not see
I swear to God.
Actually?
What is that?
So lucky.
You got it. You got it.
Turn your head.
All right. Hang on one second, ladies and gentlemen. Get your computers out, open them up to the new EISN.
What did you get? I put that there's even more than that. There is.
She didn't finish the test, okay. She didn't finish it.
So
she got-
You can copy that. We can all have the same
Yeah.
answer. We can all have the same answer.
That's so
We're the
right.
class that take that.
Yes.
Okay about that.
We can all have the same exact answer.
Oh.
All right, ladies and gentlemen, just a couple of reminders. Number one, any questions on the grade reports that I just handed you?
Yeah, can you say it all over again?
All over again.
You didn't say anything. Report.
Questions? Yes, no, maybe so? You don't want them? Please recycle them on your way out the door. Okay? The only thing that you can be missing, the only thing that any of you can be missing are labs. None of you are missing any quizzes. None of you are missing any tests. You're done with all of those. The only thing that you can be missing is a lab, ladies and gentlemen. And if it is highlighted on your sheet. And you need to get it done, and you need to get it turned in to me. Questions? Wonderful.
You know what?
Can we take a test?
High five.
That's right.
Turkey. Oh.
Take one and the rest back.
Turkey.
Make sure Jennifer gets one, please.
Wait, do you have a sheet of all the
They want to make sure they go back. What?
You have a sheet of elective.
No, I do not.
Why not?
Because I don't need to take any. Oh, it's in here. Leave one for me.
Is this our last unit?
No.
There was
It's
this
like us.
Hey.
a test.
Mr. Brand, did you reorganize?
Yeah, you're looking for my hair ties?
Yeah.
Back cabinet, second drawer down.
What happened yesterday?
Yes.
Oh, it worked. It worked.
You have 2 more units left.
Wait, we have 9 units?
9 units.
Or do you mean including this one?
Well, we haven't done this one yet,
Oh,
right?
so including.
So you have unit 7 and unit 8.
Okay.
Okay?
Okay, so like Ace, both of those units like will be up. Or will be up.
Now, that is a great plan, Alexa. If you ace both of those units,
They'll be up.
you'll be up.
Yes, I will.
Now, here's the one problem. Unit 7, ladies and gentlemen, is now going to take everything that we have done and put it all together into one unit. And just so that you know, let me do a little checking here.
He's had like all like 6 units, like 1 through 5 or 1 through 4 in the other trimester.
What's it?
Like all of the units or just this?
No, there's
Yeah, a little bit of everything because it goes back into naming, balancing equations, all of that stuff.
Oh my god, I forgot about that stuff.
Um,
Yeah, okay. I just keep forgetting to grab this front. And it's their
No, literally, I have senioritis already.
It'll stick to my brain.
We're so close. It's like summer, and then like it doesn't matter anymore. It's like basically second summer. That's weird. Oh, like
okay. Hey, listen. You have 2 units left. Unit 7 puts a lot of the things, many of the things we've been talking about together. Unit 8 test is your final exam.
what?
The Unit 8 test is your final exam. Now, just to let you know, the average score last trimester of one of my classes was a 54 on the final.
So you gotta make it easier.
Wait, you're
because
joking.
No, I gave them 50% no matter how bad they did. My low score was a 2 on it. Correct. 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 And just as a reminder, no, what I'm telling you is, number 1, be ready for putting the things that we've done together. Number 2, when we get into Unit 8, it would do you wise to practice some things rather than just, I got it, I'm good. Okay?
Is it the periodic table thing? Is
Yeah,
that what
we'll
you're
get
gonna
into
discuss
that.
then?
It's my favorite test of the year.
Oh my god.
The
Oh my
easiest
God.
one to
I heard
grade.
it's horrible.
What test?
It's
the
basically
periodic
like
table one that they did last try.
you
Yep.
like fake
That's
elements
our
and you
final
have to
exam.
put
They're
them
not
in periodic.
fake elements. They are elements that are similar to the ones here on Earth.
Yes, but they're not real.
Yes, they are. They have the same properties as the ones here on Earth do.
Okay, what are their names though?
There is vibranium.
And it's
There's
a plain
Fermium.
periodic table.
So they're not
There's
real.
Avogadro.
So
Avogadro?
like if you get
Mendelevium, Melvilium, Greenium, Redium, Bluium, Borium. So, okay, instead of worrying about that, let's worry about this, ladies and gentlemen. Today we start stoichiometry.
Oh my god.
You're a big fan of stoichiometry?
No, I'm not. I'm a big not fan of Swift.
What is it?
Okay, well, I can. So let's talk about the steps to stoich, then we'll talk about molarity, then we'll do mass to mass stoich, then we'll do volume of a gas to mole relationship, then we'll do molarity problems, we'll do limiting reactant, then we'll talk about ionic compounds in water, which we already have, and then we will finish with ions in a net ionic equation. So that's the outline of what we are going to do. Now, steps to stoichiometry, ladies and gentlemen. Stoichiometry looks at the relationships in a balanced chemical reaction. Stoichiometry allows us to predict how much product we will create in a reaction before we ever do the reaction. Down to the gram, down to the milliliter if there is a gas produced, and down to the molarity. So the steps for stoichiometry. Number one, you have to write good formulas because the questions will be 3 molar sodium hydroxide reacts with 6 molar aluminum chloride. What would be the products and how much precipitate would form? Now, again, you need to be able to write chemical equations. You need to be able to write a compound from a name. We did that. We went through that. Okay? Then you need to be able to predict what products are. We did that in Unit 4. We predicted what the products of a single replacement reaction and we predicted what the products of a double replacement reaction will be. We will review that again, but you have already had that. And then you need to tell me what state of matter things are in. And again, between the information in the problem and the products that we know we will produce in a reaction, you should be able to figure out what state of matter everything is. Then you are going to have to balance the chemical equation that you write. That's the part where you put the coefficients in front. When you add up how many nitrogen atoms are on one side, how many nitrogen atoms are on the other, they need to have the same amount on each side to support the law of conservation of mass. Okay? So we will add coefficients to balance chemical equations. Now that's stuff that we haven't done since Unit 4. Okay? Then you're going to identify what you're given. You're going to identify what you're looking for. And you're going to convert what you're given into moles. This whole unit is about taking things and getting it into moles. Why? Because a chemical reaction is actually a molar ratio of every reactant in the reaction to every product. So we are going to be looking at that. Now, here's the thing. You may be given mass and have to get it into moles. Guess what? Unit 5 formula mass. You may be given the volume of a gas and have to get it into moles. Guess what? PV equals nRT. Last unit. And then you might be given the volume of a solution and its molarity, which we have not done. And you can convert that into moles. That's what we're going to be doing in a few minutes. So, the stuff from Unit 5, the stuff from Unit 6, you're going to be using now. Now, here's the good news. We won't be giving you any of those minor formulas. The mass of A over the mass of B is proportional to the density of A over the density of B. No. The velocity of A over the velocity B is equal to the square root of the mass of B over the square root of the mass of the A. No. But you will be using PV equals nRT. Again. So all your R values you still need to know. Did you have a question? Okay, good. So you're then going to use a molar ratio to get from reactant to product. So this much reactant, how much product would you create? You might go reactant to reactant. If you have this much reactant, how much of the other reactant do you need? Or it is even possible to go from one product to another. You create so many grams of this. How much of this other stuff would you create? Doesn't matter. It all gets done the same way. Then in some problems, we're going to have to look for what is called a limiting reactant. Limiting reactant is what you run out of first. By the way, you've already been exposed to a limiting reactant. The gas law lab we did. With the magnesium ribbon and the hydrochloric acid inside the gas collecting tube. When did your reaction stop?
When there was no more magnesium.
When the magnesium was gone. Hey, guess what? That's a limiting reactant. You ran out of that. The reaction stopped. But from that, we were allowed to figure out how many moles of magnesium caused how many moles of hydrogen gas to be created. The fourth question, where you had to take the calculation from 3 minus 1 divided by 1. You were doing stoic at that time, ladies and gentlemen. And again, you need to report your answer in the proper unit. So your answers are going to come out in moles. Can you go from moles back to mass? You should be able to. We did it all in Unit 5. Can you go from moles to the volume of a gas? You should be able to. That's PV equals nRT. Maybe you will find the volume and the molarity of a solution and you will be able to take it, or sorry, you'll find the moles in the volume of a solution and you'll be able to take it molarity. We will show you how to do that. Questions? This is all in your notes, all there for you. You can refer back to it anytime you want. But what we really need to begin with, ladies and gentlemen, is this idea called molarity. Basically, when you have a reaction, there are 3 ways that we will measure things. We will start out with the grams of something, like we did in your lab with the gas laws. We began with the grams of magnesium metal. We converted that into moles. That was the start of stoichiometry. Now, I gave you a balanced equation in your reaction, in your lab, that said that for every 1 mole of magnesium, you were going to create 1 mole of hydrogen gas. Now, when we created the hydrogen gas, what did we measure about it? It's what?
Pressure?
That was one thing, but what did we actually measure inside the tube? We measured the volume. We were also able to find its pressure. We were able to find its temperature. We were able to know an R value, which meant we could get to the number of moles of it. Okay? So again, you've been doing these kind of things before. Now you're going to put them all together. The one thing you haven't done is molarity. But I talked to you during certain labs and said, hey, this is really strong hydrochloric acid. This is really strong, this acid. How strong it is its molarity, ladies and gentlemen. By the way, what do you see in molarity? Mole. Molarity is actually the moles of something per liter of solution. Moles over liters. Okay? So that is what molarity is. Molarity is the number of moles of solute, something that gets dissolved per liter of solution. So molarity could be anywhere from point something to 14 point something or more. Okay? Molarities are normally, like we use 6 molar, we use 9 molar. You could use 0.25 molar, you could use 0.1 molar. When you were in physical science doing the labs with Ms. Bolkowski or me, and you had an acid, I guarantee you it was only about 0.1 molar. Why? We didn't want it to be strong enough to burn your face off. Okay, congratulations, you have improved since then. Now I will give you acid that can burn your face off. Okay? It is expressed, the units it's expressed is moles per liter. Moles per liter. By the way, we write M for the unit to represent that. Okay? We write M. Everything okay?
Yeah.
Is there a lot on the floor or just a little? Okay. All right.
Not that one.
You sure? I will get, hang on.
I'm not locked in.
No, what?
Yeah.
We drove by it very much. We were like, why is there just
Some milk.
Somebody almost died.
Like half.
Dang it.
Strawberry milk.
Oh, what the
Sure, go ahead.
It's so funny.
No, I didn't see that.
There's towels and things you can use just to wipe up what's on the desk.
In the sun, so that it was like chunky and ew. I bet you
I did not smell it. I just I was like,
Sure.
I have all my notes on mass to mass.
I don't know how you have them all done when I haven't given them to you, but okay, go ahead.
I would have.
Well, that's good. I wish you would listen, though.
yeah,
I do.
Okay.
I know it's
It's going to be hard to do when you're out of the room.
I
All
have,
right.
I'll take
So
my
we
ear
use
off.
the unit M to represent this entire unit. Why? Because it's easier to write one letter than it is to write moles over liters. But the important thing that I want you to understand in this unit is that when you see this unit, M for moles, you need to make it into this, because this tells us more than this does. Okay? This will allow us to use this as a conversion between two units, between moles and between liters. And that is what we are going to be doing with this quite often, ladies and gentlemen. Okay? Quite often. Okay? So please remember, if you see this, 3.25 molar, that is the way we would read this. Molar, what it means is 3.25 moles of something per liter. Which means, ladies and gentlemen, this. We have been using conversion factors for a long time now. A conversion factor is when two things are equal to each other, and then we can put one on top and one on the bottom. Well, the key, or what we should be getting to with you right now, ladies and gentlemen, is you should be able to recognize this as a conversion factor. Because it is one thing over another, what it really means is 3.25 moles of something is equal to 1 liter. Which means I could write it this way if I need to get rid of the unit of liters in something. Or, ladies and gentlemen, I could write it this way. It all depends on what unit I'm in and what unit I'm trying to get to. I can use this if I want to get out of moles and into liters. I can use this if I want to get out of liters and into moles. I said this before and I will say it again. If you have no idea what to do with the problem, what should you do with your numbers?
3 sig figs.
So that's your answer. Take what you're given and get it into
Moles.
moles. So if you're given a molarity and you're given a volume, get it into moles.
Wait, so is it always gonna be 3.25?
No, could be any number.
So why would we need to change it into a different unit?
Because this doesn't mean much to me. This doesn't allow me to cancel units out. Okay? This is a shorthand way of writing this. When I write this, okay, if I take this times some liters, what will I get?
The mole.
I'll get moles.
But how do I know?
If I take this times some liters, you don't have anything to cancel out here. So my suggestion to you is to get used to seeing this and writing it this way.
But how do we know how many liters to multiply?
They'll tell you that in the problem. So, for example, in your lab, you use 6 molar hydrochloric acid. But we only use 50 milliliters of it. So take that 6 molar hydrochloric acid times 50 milliliters converted into liters. I can tell you how many moles we used. Okay?
Is it always going to be over 1 liter?
Yes. Yes. Always. Because that's what it is. It's moles per liter.
What about when we switch it? Oh wait, never mind.
It's 1 liter over the number of moles. But this would allow us to get, if we had moles, some number of moles, your answer could be in liters. This allows you to go from moles to liters or liters to moles. Either way, whichever way you need to go. That's the point. Questions? All right, good. Come on. So 3.25 moles of sodium chloride. Molarity allows you to convert from liters of solution into moles. So what is the molarity of an aqueous solution containing 40 grams of glucose in 1.5 liters of solution? So let's start by figuring out how we would find a molarity. What is molarity?
Moles over liters.
Moles over liters. So look at the information I'm given.
Grams and liters.
Okay, what's the problem with grams?
Not a mole.
We're going to turn it into moles. How do we turn grams into moles? Formula math. So we're going to start by taking 40 grams of C6H12O6, and we are going to convert it into moles using formula mass, 180.18. That is the grams in 1 mole of sugar. Okay? So when we are done, we end up with 0.2200 moles of sugar. Question?
And that's our answer?
No, that is your number of moles.
Can you not like?
Wait, that's our number of moles of 40.
Can I not like what?
Oh.
Simplify the C6H12O6.
You cannot, because it is a covalent compound, not ionic. Thank you. Good question,
Wait,
though.
so now we just put it, put the moles over 1 and do.
Not over 1, because it says this amount is put into what?
1.5 liters.
So we're going to take this amount, we're going to divide it by 1.5 liters, because that's how much solution it is in.
So do we set it equal to 1 mole?
We're calculating this number now. Okay? This number is found by taking your number of moles divided by your number of liters. Now, when we divide it, now this number is the moles per 1 liter, because we divided by the 1.5. So now we can put the capital M here, but what it really means is moles per 1 liter. So this is how we would determine the molarity of a solution. It is the moles divided by the liters that it is in. Now, again, you have to be in these 2 units. By the way, this is not a gas law. Why?
Because it's not a gas.
Because this is not a gas. This is not a gas. But on the test, I will give you information about this volume of a solution, and people will put that volume into gas laws and be like, well, there's this many moles. No, there isn't. Gas laws only apply to gases. Okay? So this is how we calculate a molarity. We take the moles of whatever we are dissolving divided by how much we are dissolving it in liters. This has to be moles. This has to be liters to give us molarity. Questions? All right. So now, how many moles of silver nitrate are present in 225 milliliters of 3.50 molar solution? Okay, silver nitrate. We're going to have to. But first, you got to write what silver nitrate is. What's silver nitrate?
AG
Thank you. At least we're in the right letters.
and
AgN2. 3.
wait, it's
AG2 and
NO3.
No, it's AG3.
AG.
AG3.
No, it's
and
AG
2.
NO3.
NO3.
Yes, it's AG NO3. I swear to God. Do not act
No,
like
AG.
no.
It's an AG to have a value of 2. Dude, we don't
Yeah.
want
Wait,
to
oh, so it'd be AG parentheses NO3 too.
I don't know, just do it.
Question
Just
mark?
you know how to do it.
Question mark?
That makes sense because it's nitrate. Mr. Brand, you do it.
I feel like I told you the right answer.
I'm trying to do it in my head, and I'm not doing it.
Yeah, me too.
I wouldn't do that unless you've been teaching chemistry for 20-some years.
Oh, AG's plus 1.
Oh.
Good.
So we
So
would
then
write
we-
AG.
Okay.
And
Which answer? Because I got 10.
It's AG NO3.
It's AG NO3.
I told you that.
Why?
Like 3
What's the
times,
NO3?
like, ignored me.
I
Negative
swear.
1.
Oh my god. Oh my god.
We
So
got that.
AgNO3. Good job. Nicely done.
Thanks.
12 hours later, but we got there.
It was like
It's not the quantity of time, it's how well it's spent. Okay, so you are right, Cynthia. Main thing, we have to take this milliliters and convert it into liters. Again, I do not need to see how you do this. You should know how to go from milliliters to liters. Okay? If you don't, ladies and gentlemen, the way we get from milliliters to liters is 1,000 milliliters equals 1 liter. But again, all you're doing is sliding the decimal 3 places to get from milliliters into liters. Next, ladies and gentlemen, oops, sorry. We're going to take this times the molarity. Now, again, if I wrote that as just a giant M, you would not see what happens to the units here. What happens to the units here? Which ones? Which unit? Liters. Yes, absolutely correct. Liters cancel out. What unit am I left with?
Mole.
What unit did it ask me for?
Mole.
Boom, you're done. All you need to do is finish this out and you are done, ladies and gentlemen. That's how many moles. Hey, you know what? We can make this problem just a little bit harder. How?
No, please don't.
Ask you to put it into grams. Oh my gosh, we'd have to use formula mass. That isn't that hard.
I'm a big believer in not doing too
I'm
much
serious, do it. I
work.
want to see.
I really love to just get it quick.
You definitely need to look up the word love in the dictionary.
That wasn't that funny. I don't know why I laughed so much.
Bro,
What
it was
is the,
just so
like,
funny.
definition?
So if we were going to mass, what do we got to have in our conversion factor?
1 mole.
Where?
On the bottom.
1 mole on the bottom. What on the top?
Okay, I think chemistry.
The formula mass.
All right. What's the mass of silver on the periodic table? Nitrogen. What's the mass on the periodic table? Oxygen.
16.
So 48, 14.01, 107.87. So that is 0.88, 9, 6, 169.88. So take 0.893 times 169.88. We should end up around 153, maybe a little less than that. Somebody do the math. I'm not doing it. You wanted it done, so let's go.
Austin's got it. I was gonna say someone else. I don't even have a calculator, bro.
151 plus
I wasn't bad. I would said 153. 151 point what? 7.
I agree with that.
Me too.
Me 3.
Good, because it should have been 152 grams.
How do you know that?
Well, look at the problem.
I have 7 years.
Why'd I round it to 152 grams?
3 sig.
Thank you,
figs.
Austin. 3 sig figs.
What?
That was a great impression, Alexis. Why are you just
Teach your class. Teach. I can't be held accountable. Stop looking at me.
Oh my god, did she leave you speechless? Wow.
Yeah, no, I got him good. I got him good. So funny.
How many milliliters of solution are necessary to have 12.5 grams of magnesium chlorate if the molarity of the solution is 0.250 molar?
Thanks. You can have it if you give me a
Okay, 12.5 grams of magnesium chlorate. What do we need to do to it? Can't turn it into liters.
Oh wait, we're trying. What are we doing with magnesium?
How many milliliters of solution?
Oh, we have to turn it to moles.
Why?
Because it's in grams. So we have to turn it to
Correct. Okay?
doing
What you're going to find is that anytime you're giving grams, you're going to have to put it into moles. You're going to have to. Why? I can't use molarity with grams. I can use molarity with moles. And I can get to liters. Why? Because molarity is liters and moles. Okay? What I can't do is go from grams to there. So again, hopefully, ladies and gentlemen, you remember how to get the formula for magnesium chlorate. Magnesium is a +2 ion because it is in the second group on the periodic table. Chlorate is a -1 polyatomic on the back of your sheet. Because you are having 2 of these to balance it out, you need to make sure you put it in parentheses, ladies and gentlemen. Okay? So, formula mass, ladies and gentlemen. Okay, good. How did we get that? How many magnesiums? 1. What's the mass of each one?
Magnesium is 24.3.
Okay. Chlorine, how many?
2.
2.
35.5.
Oxygen, how many?
2,
Oxygen, there's 6.
7, 6, 6.
Why did you skip the I?
16.
That's not I, that's Cl.
Oh yeah.
So, 24.305, 70.90, 96.0. I understand that, but I'm quicker doing it that way than you guys are with your calculator. So I guess it all works out in the end. 191.205.
Where's your units?
It's grams per mole.
Right now?
I don't need to. Why?
Oh, well, you don't write it.
You're right, I do, because there it is. Okay? This will get us into what units, ladies and gentlemen? Anybody want to take a guess what kind of number this is going to be?
Small, very small.
Why a very small number? Whole number? A whole number? Really? Really?
Taking a small number divided by a big number, which equals a very small.
Thank you. So at least you're thinking about your math. That's good. That's good. That's wonderful. I love that when people start actually thinking about their math. A little number divided by a big number. 12 divided by 200. $12 split out over 200 people. You're not getting much money apiece. Okay?
Probably like
So,
10 cents.
0.065373 moles.
There's not even enough cents for that.
Okay? So there's what you get, ladies and gentlemen. Now we are going to take this and we are going to use molarity. But again, if you think about molarity, the suggestion that I make is to think about it this way, ladies and gentlemen. This is 0.250 moles of magnesium chlorate per 1 liter. Okay? Now, if I bring this down here, what's the problem?
We have to divide.
It won't cancel out.
Won't cancel out. So I am going to take and flip it. 1 liter over 0.250 moles, because now it does cancel out. Okay? It does cancel out. And by the way, you're taking a really small number divided by a fairly small number. We end up with 0.26149 liters, because that's the unit here. Wanted to know how many milliliters, so times it by 1,000, ladies and gentlemen, to get 2 milliliters.
Why aren't you using like a pencil?
2 mils.
You get to 261 milliliters. Questions?
I got like 100 pack of those. Like not of the black ones. But
Okay.
or like what were we talking about?
How many grams of tin 2 carbonate are present in the 142 milliliters of 2.33 molar tin 2 carbonate? Yeah, last time I checked.
I need a black one.
Carbonate is CO3.
Maybe time to find that periodic table you haven't used in a little while, ladies and gentlemen, like since yesterday. Have it out. Have it near your stuff. So for me to find the grams of this, what do I actually have to find, ladies and gentlemen? I got to find the moles. I can convert from moles to grams very easily, but from this information, a volume and a molarity, I got to get to moles. I got to get to moles. How do you get to moles from a volume and a molarity? No! You went back to gas laws. Don't do that. These aren't gases. How do you get 2 moles given a volume and a molarity? Converting milliliters to liters. Okay, and then what?
You multiply them together to cancel out the
Multiply
liters.
what together?
The liters and the molecular, or whatever.
The
it's called.
molecular.
The M. What is it called? Molarity.
Okay. So we're going to convert the milliliters into liters.
I just learned about this today.
Then we are going to take this times the molarity. Now again, if I write this as just 2.33 m, you do not see the moles over liters here. Okay? Liters will cancel out. You will be left with the moles of tin carbonate.
So that number is the same thing as 1 liter of tin carbonate.
Keep this.
No, another one. 0.30.
That's just the moles. Now think about this.
Oh.
Think about this. I have a container that has a liter of water in it and 100 grams of sugar.
Oh, wow.
If I take half of that into another container, what do I got?
Half of a liter and 50 grams of sugar.
50 grams of sugar. The sugar's evenly spread out, right?
Usually.
Will be in a solution. If not, it's not a solution.
Oh.
Okay? So if you take part of your solution, you're getting part of those moles. You're getting part of the grams because, again, grams and moles converted between the two very easily. Okay?
Did you mean to put the big M on top of
It should have said moles there.
Okay.
Should have said moles. So, now what do I do with that?
Grams.
How?
Formula mass.
Unit 5. Formula mass. Here's the formula mass for tin carbonate. Grams of tin carbonate over 1 mole, ladies and gentlemen. Moles and moles cancel out. We are left with grams.
What's the biggest formula?
So basically,
I've never seen it, but if you were to do the formula mass of DNA, it would be pretty huge.
Wait, really?
Yes.
Oh.
Yes. So,
wait. So basically, what's the answer?
what's the answer? About a third of 178. I mean, it's about a third of 178.
Okay, so what we find in grams is
So,
the same thing as 142 milliliters, and I'm so confused.
what's confusing you? Which of these steps is confusing
What
you?
are we finding? So we find the grams.
To find the grams.
2.3 mole grams.
If we had all of this solution, we would know how many moles there are. But we don't have all of it, right? We only have 0.142 liters. Okay? So the first thing we do is we figure out of these moles, how many of them do we got? By taking the volume times the molarity, giving us the moles. So this is how many moles there are. This is how many moles you have. Not in the whole thing, in your sample. Your sample is only 142 milliliters, so you don't have all of those moles. You only have a portion of them. That's the portion of moles that you have. So now I'm going to take that portion of moles and I am going to convert it into grams using formula math. So 178, about a third of that is 60. 59.1 grams of tin carbonate is what I would have from that portion
From 142.
of this solution.
Oh.
Questions? Oh, good. Perfect place to stop. Tomorrow we'll talk about mass to mass toy.
did great today, guys.
Again, your guys' knowledge of the vocabulary adjectives that you use is just horrendous.
We did do great. Like, we did good. Really not, right?
Well, I hope you did. I really do, because to be honest, this is the easy stuff. So let's not mess up the easy stuff. Let's take advantage of the easy stuff, and then when it gets a little bit harder, we'll work through those things.
Hey, Graham, what are you teaching next year?
What am I teaching next year? Auto shop and cooking classes.
Sounds about right.
The school's gonna burn down.
Literally.
From which one? The auto shop or the food classes?
Oh.
Well, that's funny. My wife is still alive after 27 years of me cooking her meals every night.
You cook? That's shocking.
Every night.
That's pretty awesome.
Why is it shocking? My parents ran a restaurant for 18 years.
Really, what restaurant?
Brand's Place.
Mr. Brandon
Aw,
Moore.
So,
What are you cooking
What?
tonight? What are you cooking today?
chicken parm sliders.
Ooh, that sounds good. I'm hungry.
She eats it because
Cynthia,
she feels
you
bad.
need to think about this for a minute.
She feels
Do
bad.
you think this body got this way from meals that burn all the time? Think about it. Come on, please.
No, that's
Never mind. Thinking's not your strong suit. I understand. I understand.
a lot of people.
Wait, why are you opening it more?
We gotta clean up, guys. The bell's about to Okay, and they cleaned up faster. Yeah, because it's an amazing job.
I mean, I was
Guys, what do you rate?
$10 for my next paycheck on VIP and just to impress everyone. To be honest.
$10 for VIP is crazy.
I know. I just love dressing.
I like
up.
VIP.
But I love dressing up as you guys.
I paid $10 for Spotify, or like 11.
Premium is worth it.
Guys, I made $40 off the taxes.
That's it?
Yeah.
I have 300.
I haven't worked as much as you, and I don't get paid.